Alright guys, the moment is finally arrived and I'm going to explain Fourier Transform for you now. Believe me, if you get this Fourier Transform clicked in your brain right now, whole of your engineering and further education will become an absolute smooth sail, because this is one of the most profound insights made in advanced mathematics connecting to engineering. From now onwards, any equation that you see, you will be able to appreciate it beautifully if you get this clicked. But let me caution you, it will take multiple revisions for you to understand this entirely. You will have to hear all the previous 4 series, and I hope you are ready now to absorb Fourier Transform. Here we go. Fundamentally, what is Fourier Transform? You have any signal. I am speaking to you right now through voice. I'm disturbing the air molecules around my mouth with my vocal cord to create a specific sound pattern. Therefore, a frequency emerges from my mouth. Just not one frequency, but I'm modulating, I'm changing my voice, and so that I can speak words. So there are multiple frequencies coming at different points of time to help you make sense of what I'm saying right now. And how is this getting recorded into the microphone? There is an analog to digital converter. Before that, a transducer that actually understands this air molecule movement and converts it into analog signals to even make it convertible into digital. That is when analog to digital signal conversion happens. So now, all that said, you cannot store this voice as air molecules moving left and right, and it is impossible to store it inside a phone. You can store it as a function of frequencies. Now, this smart man called Fourier, he presented this idea, and this stayed apparently so for more than 100 years, that any time-based signal, what is a signal? Right now, time-based change of my voice is amplitude, frequency, lot of things are changing with respect to the time, because I'm recording this audio only for 6 minutes. So within the 6 minutes, if you notice, my amplitude of the signals will be drastically different. My frequency that I pick, because when I shrill my voice out or when I go low frequency, there is so many things are changing. So this is the period of window in which my signal is changing. What did Fourier say? He said you can take out all the frequencies away from this particular time window if you could intelligently understand the pattern behind it. There is a pattern behind it, and if you can intelligently understand it, you can take out all the frequencies, and by selecting only the top 20, 100 few frequencies, you can completely reconstruct the signal, and therefore you can store it inside your phone, send it over the internet, and do everything with it. And it just not applies to voice, believe me or not, applies to images, applies to heat transfer and whatnot, and everything in this world can be modeled by this beautiful phenomenon. What is at the core of it is, how can a signal be represented? Frequency, what is all these frequencies, right? Frequency is cycles per second. Changes in amplitude, changes per second is frequency. Higher, lot of changes per second, high the frequency. Less changes per second, lower the frequency. Why is frequency important? You are trying to model the rate of change using this entity called frequency. How is it connected to your imaginary real plane? And the circle in trigonometry is how fast you go around this circle. Producing these sine waves can determine what is the frequency at which this particular signal is getting propagated. You can go really fast, you are actually producing a high frequency signal. You go really slow around the circle, you are producing a low frequency signal. And can you add multiple speeds? Therefore, can you add multiple sine waves to produce new waves? Yes. Fourier proved that any signal can be represented as a sum of sinusoids given with a specific amplitude chosen so that they cancel out at times when you do not need them, and they will add to whatever you want when you need them. And that is the beauty of Fourier Transform. இது புரியலைன்னா திருப்பி இதை கேட்கணும், ப்ளஸ் இந்த லிங்கை பார்க்கணும். பார்த்தாக்கா you will have a clicking moment when you will understand that hey, any signal has a periodicity and you can start any signal at a relative point so that it correctly adds together constructively at a specific point all the sine waves, and they cancel out when you don't need it, and the magic of the Euler's formula comes into picture. The cosinusoid and sinusoids come into picture. Cos theta plus I sin theta comes into picture and does this magic for you that a signal can be represented in this form. Once it is represented as a summation, இதுக்கப்புறம் பாலினாமியல் பூந்து விளையாடிடலாம், Fourier transform கண்டுபிடிக்கலாம், discrete Fourier transform you can find, you can enjoy fast Fourier transforms and many other transformations which are all possible in engineering.